Okay, now I'm cool. Okay, now I'm actually on. I guess I'll do my intro again. Welcome everyone to my LeetCode bi-weekly contest 425. This is really. Welcome everyone to my LeetCode bi-weekly contest 425 live stream. The contest has just started, so I'm not gonna waste a lot of time explaining. But do check out the rest of my content on my channel. If you enjoy LeetCode content, come join us every week and for the contest. I normally do not share code during the contest, but stick around after the contest to see answers for questions. If you need help, type in the chat and I'll get back to you. If you don't see me do anything on my screen, that's normal. I'm probably working on a separate screen. Okay, with that, let's talk about the first question. Minimum positive sum subarray. You're given an integer nums and two integers L and R. Your task is to find the minimum sum of a subarray whose size is between L and R and whose sum is greater than 0. Return the minimum sum of such a subarray. Contiguous non-sequence, okay. So L equals 2. R equals 3. The minimum sum of such a subarray. And the numbers can be positive or negative. So you might presumably make the... Yeah, it might presumably be bigger if you include more. If no such subarray exists, return -1. So let's say it's 3 minus 2, 1, 4. Which is the smallest positive sum, hence the answer is 1. Okay, cool. There's no subarray of length between L and R. There's a sum greater than 0, so the answer is -1. Okay. So basically, I think you enumerate all the possible subarrays. Just look for all the possible subarrays. How big are the arrays? So 1000 length is less than 100. Okay, cool. So for... Oh, I need code on a separate screen. So probably what I want to do is just enumerate the different subarrays. So let's say L equals to 2. I'm gonna start with for J in range. So if L equals to 2, yeah, I'm just gonna brute force this. I'm gonna really brute force this, because I don't think... Okay. Let me see if this works. Alright, accepted. So actually question 1 you can do a bit more fancy stuff, but I just did a brute force and it works for question 1. Hey. Hi Sasi Praveen. Hi Dini Kings. Are you on the second question? Yes, I just got to the second question. You are given 2 strings S and T, both are anagrams of each other. An integer k, your task is to determine whether it's possible to split the string S into k equal sized substrings, rearrange the substrings, and concatenate them in any order to create a new string that matches the given string T. Okay. So we know S and T have the same set of letters. Have the same set of letters. What we want to do is to step 1, if k equals to 2, I want to split S into 2 k equal size substrings. I'm going to split S into, so substring is a contiguous so there's only one, I'm going to split S into 2 substrings, and there's really only one way to split S into 2 substrings. It's contiguous. So if I split S into 2 substrings, S is AB and CD. That's the only way to split it in 2 substrings. And then my job is to determine if there's a way to get from here to here. Yeah. Okay, that makes sense. Basically, what I want to do is also split T into 2 substrings. Okay. Yeah, I also want to split T into 2 substrings and then compare if I can swap those substrings around. So second example, okay, S is divided AA, BB, CC, okay? And then B is BB, AA, CC. And then you can see that you can rearrange the substrings around. You can rearrange the substrings internally, or you can rearrange the order of the substrings. But you cannot swap letters between substrings. So for instance, in example 3, you have A, B, B, C, C. So you split into 2, you get A, B, B, C, C. T equals to B, B, A, C, C. So this will not work. These two will not work. Okay, so this is pretty straightforward, I think. Essentially what happens is you want to take all these things and you want to sort them. You want to normalize them. And you want to see whether they end up the same. Yeah, I think that's pretty much it. Try to do the second question. Yeah, so Denise King, do you understand what the question is asking for? So basically what it's asking for is that step 1, you want to take S, whatever S is. Let's say S is let's see example 1. Let's say S equals to A, B, C, D. T equals to C, D, A, B. Right? Step 1 is to divide them. If k equals 2, you divide them into 2. So S is A, B, and C, D. T equals to C, D, and A, B. And then you want to see whether you can sort of match them or not. So S is A, B, and C, D, right? This matches this, and this matches this. So yes, the answer is true. Whereas in the other case, in question part 3, S equals to AAB, BCC, T equals to BBA, ACC. No matter how you arrange these letters, you cannot get them to look the same. So this is going to be false. This is going to be false. So that's what this thing is asking for. So essentially what you want to do is, first step, you want to break them up into substrings. And then after that, you want to figure out if the substrings can match with each other. Can you rearrange the substrings with each other and rearrange the letters within each substring such that they match each other? Yeah. Okay. That's all I'm willing to do now. That's all that's all the help that I can give you right now. But if you need more help, we can arrange that. So S and K are the same length. S and K are the same length. Okay. Yeah, so if Dini King, you have more questions, let me know. But try it out yourself. STD out. A, B, C, D. Okay, cool. Oh crap, I got wrong answer for question 2. K equals 1. Damn it, I hate this. Okay. T equals S equals NC, C equals CN, K equals to 1. Huh, interesting. I also got wrong in question 2. Yeah, do you get... Yeah, I got wrong in 623 out of 711. Which one do you get wrong in? It doesn't... The answer looked wrong to me. I feel like my answer is correct. Yeah, 623 and 711. S is NC and T is CN and K is 1. Yeah, I don't know. Yeah. Yeah, I'm gonna skip it. I'm gonna go to question 3. I wonder if it's a wrong test case because I'm pretty sure my answer is correct. I'm pretty sure my answer is correct. S into K equals size. Oh, maybe I'm wrong. Maybe my answer is not correct. Let me read the question more carefully. So, you're going to split them and concatenate them in any order to create a new string that matches T. Yeah. Let's try this one. Oh, it's accepted. Okay. I was wrong. I read the question wrongly. Okay. Cool. Question 3. Minimum array sum. You're given an integer nums and 3 integers k, op1 and op2. So for question 2, I was wrong about question 2. When you split the string into the k equal substrings, you don't get to rearrange. You can rearrange the substrings with each other. I thought you can rearrange, like anagram rearrange the substrings, but I don't think you can do that. I thought this rearrange the substring means that you can take the substring and you can rearrange it into another substring, but you can't do that. You can rearrange the substrings amongst themselves. So concatenate them in any order. So I actually misunderstood the question. I feel like the question is just the phrasing is bad. Like, come on. You are given an integer array nums and 3 integers k, op1 and op2. You can perform the following operations on nums. Okay, Rohan Sharma, let me take a look at yours. So JVDK, VJDK, expected output true, expected false. So if you split this JVDK is, yeah. So JVDK, let me just talk talk to you since you're here. Yeah, so JVDK, and what's the other one? VJDK, VJDK, right? They can't match because this and this cannot match. It says here rearrange the substrings, but you're actually not supposed to rearrange this JV to VJ. You cannot rearrange this. This is wrong. This thing is like this thing is lying to you. So you cannot rearrange this. So if it's JVDK and VJDK, you can't. Obviously, you're not able to make them match. Yeah, so you can check. You're given an integer. Minimum array sum. So let me see. You can choose an index I and divide nums I by 2, rounding up to nearest whole number. You can perform this at least OP1 and not more than once per index. Okay, you can choose and subtract k. Oh my god, this is... But only if is greater or equal. You can apply it to the same index. Do you do operation 1 or operation 2 first, or both? Minimum possible sum of all elements in nums after performing any number of operations. Okay, let me see. Okay. So what you want to do, if you want minimum possible sum, then of course you need to divide first before you subtract. If you subtract first and then you divide, it's not going to work. So if you're going to do on the same index, you have to divide first and then subtract. And what you want to do is you can look at those things separately. Probably what you want to do is you got two, you have op1 times divide by 2. And then op2 times minus k. Can't below 0. Okay, probably what you want to do is you want to pick the biggest number and divide them by 2. Oh, but then you want to I think you want to pick the biggest number and divide them by 2. And then after you've done that, you want to subtract k from the biggest numbers. From anybody, yeah. So first you pick the biggest numbers and divide them by 2. Okay, you probably want to sort them first. So let's see what happens. So apply operation 2 to nums 1. So 8, making it 5. Okay, and then you pick, like, it makes sense, right? You pick the biggest number, you divide it by 2, and it becomes 10. And then the remaining result becomes this, which has the minimum possible sum of 23 after applying the operations. Yeah. I think you... Yeah, you probably want to divide things by 2. Yeah, well. Alright, I see some people coming in. I see 16 people watching. 15 people watching. Welcome to my stream. I don't normally come at this time. I don't know how many of you guys are regulars, how many people are new to the channel. If you're new to the channel, welcome. As a disclaimer, I don't show code while while the contest is running, but stick around after the contest. I'll go through all the questions. If you haven't, remember to like and subscribe to the channel if you like it. If not, at least like the video. That helps me a lot. If you have questions, ask on the stream and I'll come back to you. I won't show any answers, but I will answer questions on stream. Let me see. Let me make sure OP1 and OP2 are smaller. Okay, this makes sense. For nums. Can't be medium, right? How can, if I just pick the biggest number, is it really medium? No way. This is crazy. Only if num's I is greater or equal to k. Oh, wait a second. So I cannot pick numbers. Wait a second. If there's a trick, there's a little trick here. So at first I thought you just arrange the biggest numbers, right? And then you subtract the biggest numbers. But I don't think that's the right way. Because if you have a number, if the number is number is 2k. Okay, let's say 2k. If num larger than 2k, then what you want to do is you want to divide by 2. You want to do OP1 and OP2. If the number is between k and 2k, what you want to do is you don't want to do 2OP2. You just want to do OP2. Yeah, you don't want to do OP1 because OP1 will divide it by 2 and it won't be 0. Yeah, you want to do OP2 and then you'll have the biggest impact. If the number is smaller than k, then you cannot do OP2 and then you do OP1. Oh, interesting. So it's not that obvious. It's not that simple. Yeah, I guess the answer is that it's not that simple. If it's larger than 2k, so it round down, right? So it round up or round down. So if it's larger than 2k, if it equals to 2k, you divide by 2, it becomes k. Oh. So if it's larger or equal to 2k, what you want to do is to divide it by 2 and minus a k, and then you become 0. If it's less than 2k, you don't want to divide it by 2. Because you divide it by 2, you can no longer minus k. And then it will not be good. It will not be fun. Instead, you want to minus k right away. Because that creates the biggest impact. Okay. Let me see. Okay, I can sort nums a bunch of times. It's not a big deal. Okay. I don't have to be ultra efficient here. So first step, I'm gonna take all the big numbers. I'm gonna get rid of them, and then now everybody is smaller than k. And what I want to do is I want to reduce them by k. Okay, let me just read through this to make sure I'm reading it right. Yeah, I think this is correct. So example 2 is a good demonstration of why you cannot divide all the big numbers by 2 first. So if for instance I divide 3 by 2, then it becomes smaller than k. I cannot use my OPT2, my OP2. Oh, okay. Question 2 is... Oh, I got a mistake. Damn it. Output is 4. Output is 3. Oh, it's a mistake. Let's see what any questions on chat. Also got wrong too. Yeah, biggest divide by 2 most probably. Can you solve question 2? Yes. Yeah. Question 3 is greedy. Yeah, question 3 is greedy. Some kind of greedy. I will not give you the details. You have to work out details yourself. The only hint you get is that it's greedy. Okay, I think question 3 I got it. Let me double check question 3 because I don't want to get the bug. The bug is like 5-minute penalty. I kind of hate it. I hate it so much. Feels so unfair when you get the 5-minute penalty. Uh, okay. Okay, let's try my luck. See if I got question 3 right. Wrong answer. Ah, damn it. Stupid. I hate it when I get wrong answers. K is 2. So if I divide by 2 and round up, I'm going to get 3. Wait a second. This description is misleading. So if you only have one thing, D1 OPT2 is 0. Oh, OPT2 is 0. Wait, how did I get 1 then? Oh, this is so misleading. 2 times k. Okay, I got a bug in my code that I'm trying to figure out. I equals to 1. How can I be equals to 1? Two times k. Yes, I equals to 1. Larger or equals to 2 times k? Let me see. Let me take a look at my chat. Web Slick, good morning. Hey, how's it going? Good to see you again. Shriram Rajkumar. 3 is not recursion. 3, is greedy. I think it's greedy. I'm still solving it, but I'm pretty sure it's greedy. Okay, let me see. So I equals to, okay. So it's 19 divided by 2, 7. Round up is 10 minus 3, okay? So 8, 3. Two, 3, 3, 8. So I is smaller than OPT. OP2 equals to 1. Huh. Hmm. 9511. Okay, so 9 divided by 2. Expected 0. Why is it 0? Oh, 9 divided by 2 first. Ah, crap. So if 9 is... Okay. So if okay. Okay. This should no, damn it, it doesn't work again. What's wrong? There's so many edge cases for question 3. I thought I was almost done. Recursion. Okay. Yeah, I just saw it and used greedy approach. You can use recursion too. I'm not sure how will you use recursion. Yeah, I'm not sure how you will use recursion. Yeah. OP1 equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then OP2 equals to 4. Four, 3, 1. So 4, 3, 1 times 2 is 862. So the first one, I'll use both on the first one. It becomes 10. 4, 3, 1, 8, 6. Four, 4, 1. 4, 3, 1, yeah. So it becomes 10. Okay. And then what I'll do is I'll find 4. 4, 3, 1. Damn it, I'm off by 1 somehow. So I'll divide this by 431. Okay, I'll divide this by 431. I'll minus this 431. I'll minus this. So 1, 2, 3. Yeah. Why is this wrong? Pretty sure this is correct. Okay. I'll try the fourth question first. Okay. There exists an undirected tree with n nodes from 0 to n minus 1. You're given a 2D array edges of length n minus 1 where edges I equals, okay, so it's a weighted undirected tree. Your task is to remove 0 or more edges such that each node has an edge and most k other nodes where k is given. The sum and most k other nodes where k is given, and the sum of the weights of the remaining edges is maximized. Return the maximum possible sum of weights for the remaining edges after making the following removals. Okay, so let's say these are the edges and k equals to 2. So every node must have at most 2 neighbors. So this guy has more than 2 neighbors, so he has to delete 1 neighbor. So he'll delete the cheapest node. Okay, that makes sense. Okay, let's check this one out. Let's see the other example. 0, 1, 2. So 0 and 1 is 5. 1 and 2 is 10. 0 and 3 is 15. 3 and 4 is 20. 3 and 5 is 5. And then 0 and 6 is 10. And then, yeah. So k is 3. 1, 2, 3. So this 3 needs to delete 1 edge. So in this case, you'll again delete the cheapest edge. When will you not want to delete the cheapest edge? You will not want to delete the cheapest edge if your neighbor also needs to delete edges. Yeah, you would want to delete the edge if your neighbor needs to delete an edge. Also needs to delete edges. Like if this, yeah, you delete this is the cheapest edge. But if your But let's say this is the graph, and if k equals to 2, then you want to delete this edge instead of this edge, or this one, because that will reduce. Yeah, that will make this cheaper. If both of them need to delete edges. If they don't need to delete edges, then it does. If only one of them needs to delete edges, you have to see which of your neighbors need to delete edges. Okay, so when you delete an edge, what happens? When you delete an edge, yeah, I have an idea for this. So I think for P4, what I might do is to sort them based on their weight from heaviest edge to lightest edge, and then find all the edges let me see, what if it's something like this. And your goal was 1. What is something like this? And your maximum was 2. So you don't want to delete this edge. You want to delete one of these because these guys are criminals. I don't know. I don't know what the right strategy is. I don't think this is a graph problem though. I don't think this is a graph problem. I don't think this is a graph problem. I think this is a DP problem. I think this is a dynamic programming problem. Okay, I'm going to solve question 3 first because I'm very annoyed. Question 3, I don't see why I got it wrong. Okay. I don't see why my answer is wrong. I'm kind of angry at this a little bit. Okay, so So one of the divisions is wrong, but which one is wrong? How can this be? I don't get it. So 851 divided by 851 divided by 2 is round up. 684 divided by 2. Okay, I don't get it. Why is this not correct? I don't get it. So if 9 divided by 2 is round up, it's going to be 5 minus 5. 9 divided by 2 round up. There's no way this is... I don't get it. Explain test case 1. You mean question 3? So Shuram Kumar. Oh, you mean question 4? Let me see. I don't know question 4 either. So question 4, basically test case 1. This is the graph that you get using this. The best way to do it is to delete this, because k equals to 2, right? Everybody can have at most two neighbors. So this guy over here has 3 neighbors. You delete somebody. In this case, we're going to delete the cheapest node, the cheapest edge. So 0, 2 is 2. You delete it. These 2 are more expensive, so you keep them. Yeah, but I don't know how to generalize it to more stuff. I'll have to think about it. I think it's probably some kind of dynamic programming problem. It's some kind of dynamic programming problem when you have to count, for all the edges. Sorry, for all the nodes. I think it's some kind of dynamic programming problem. So you want to arrange all your edges from the biggest to the smallest. So it's like 3, 4, 20. And then all the way to, I don't know what's the smallest, 3, 5, 5. And then at each one, you can either take this or don't take this. And you have to look at 3 and 4, whether nodes 3 and 4. Where did I get 3, 4, 20? Oh, it's the second example. So you look at the nodes to see if they need if they need to reduce their neighbors. If they need to reduce their neighbor count. I think it's some kind of dynamic programming problem. That's my guess. Yeah, but it's got some weird bug with question 3 that it's like off by 1. My answer is exactly off by 1. I don't understand why. So I need to solve that first. Yeah, okay. So when is it better to divide rather than minus k? So if k is 5, if I divide this, okay. So let's say 7 divided by 2 is going to be 4. So it's going to be minus 3, basically 6. Divide by 2. So 6 divided by 2 is 3. Yeah, I don't get it. I want to choose the smallest ones. What if I divide the 7 by 2 in 7 minus 6, 6, 6, 7, 8. If I divide them by 2, one. Can you tell me that test case for question 3 where you fail? Yeah, sure. So the question 3 test case that I fail is test case number 765 out of 711. Yeah. So we don't give solutions. 765 out of 711. I think it's like it's a bug in my code. It's a bug with like it's off by exactly 1. So it's like a minus or plus larger equals or something that I'm messing up. I'm going to divide, everybody gets divided by 2. But what if I subtract? Subtract 3 from the... Subtract 3 from the 7 instead. Everybody's gonna get divided by 2. Is I subtract 3 from the 7. Oh, so if it's an odd number, wait a second. If it's an odd number, yeah. Damn it. If it's an odd number, then it makes sense to subtract first and before dividing. So it's not so simple. Or I can divide them first. So 3, 3, 3. I can't. Oh boy. If I don't solve question 3, I'm so screwed for this. Yeah. Question 4, I don't know what the approach is. So 765, 711. Answer is 11. Web Sleek, which one are you talking about? Web Sleek, Are you talking about question 3? No. That's 19 and 20. Yeah. Test case. Answer is 11 or 8. So question 3, I have off by 1 error because of the way even and odd numbers work. I try a greedy algorithm. Okay, Sriram Rajkumar. This test case for question 4, please explain. Okay, sure. Let me see if I can help. So 01 14 03 44. 01 14 03 44. And then 32 37. 32 37. And then k equals to 1. K equals to 1. So for this case, 0 and 3 are both in violation. So you can either delete both of these, or I can delete this one. You have two choices. It depends on which one is cheaper. So in this case, I think deleting this one is cheaper. Delete 44, you're going to left with 14 plus 37, which is correct. But if you delete this two, you delete 01 and 32, that also works, but you'll end with 44. So the answer is basically 44 for this. Okay, I want to solve question 3. I'm doing something really wrong for some reason. I get it off by 1 error. No matter what I do, it's still off by 1. I don't want to give up. Well, I don't want to give up, but while I have folks here, I do want to say, if you, I do want to plug before the contest ends, that if you enjoy this contest, make sure you like and subscribe to my channel. I would appreciate that very much. If you leave a comment saying what you, how many questions you managed to do in this contest, it will help out very much. Yeah. Damn. This is rough. This is a rough day for me. Rough weekend for me. I can't get question 3 to work. You know what? Oh my god. Is this off by one error? Yeah, there's something that I'm missing. Some logic error that I'm missing. Yeah, I don't think I'll be able to do it. I didn't do DP though. I just did a greedy algorithm. Maybe I should have done DP. It's too late for me to change now. I thought I can do it by greedy. It does look like you can do it by greedy. Well, 3 minutes left on the clock. I hope everybody is finding success in their contests. There are 7 of you guys left. I'm going to take a swig of water, and I'm going to come back and we're going to talk about answers. We're going to see if there's some approach. I don't know how to do question 4 either. Yeah, I don't know how to do question 4 either. But we'll go through question 1, 2, and 3 when I come back. Give me 1 second. I'm going to drink some water. Okay. Bro, if I remove 0 to 1, then each edge has 1 node? No. If you remove 0 to 1, 3 will still have 2 outgoing nodes. 3 will still have 2 outgoing nodes if you remove 0 to 1. So you have to remove 0 to 1 and 3 to 2. If you want to do this, you have to remove both 0 to 1 and 3 to 2. So that's be removing too many things. If you remove 0 to 3, you only remove one thing. Yeah, I know. You know what? Programming, 50% of programming is understanding the English language. Yeah, alright. I think time is almost up. Alright, time's up and the contest is over. I hope everybody had a good contest. I'm gonna be quick because it's really late in my time right now. I'm gonna go to bed soon. So I'm gonna jump right into explanation. Unfortunately, I didn't do too well this weekend on either of my contests. Damn, I need to practice, man. I need to practice. I do hope that you guys are faring better than me. So we'll see. We'll see how it goes. This is 425. Alright. We are discussing solutions for LeetCode Weekly Contest 425. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. You'll help me out so much if you just click the like button. If you enjoyed this video, just click the like button on the live stream as you are right now. Okay, cool. Let's go through the answers. So starting from question 1, minimum positive sum subarray. You are given an integer array nums and 2 integers L and R. Your task is to find the minimum sum of a subarray whose size is between L and R and whose sum is greater than 0. So for instance, if nums is this, L equals to 2. So what are the possible subarrays with length 2? 3 minus 2 minus 2, 1, 1, 4. What are the possible subarrays of length 3? 3 minus 2, 1, minus 2, 1, 4. Right? So the idea is you list out all the possible subarrays of that length from L to R inclusive. And then you calculate the sum and you return the best. So the best is defined as the smallest that is greater than 0. So that's pretty straightforward. What you want to do is you want to I is basically the length of the subarray. It goes from L to R plus 1. Okay. and then j is the start. So if j is the start. So notice that when the length of the subarray is 3, you can start at 0 or you can start at 1, but that's it. You cannot start at 2 and 3. So j is basically the length of nums minus I plus 1. So this will tell you where you can start. Like for instance, r is 3, the latest you can start is at index 1. So what you do is you just do some kind of sum to sum them all up, and then you find the best. This is pretty straightforward. If there's no best, then you return -1. Okay. Alright. Question 2. Rearrange k substrings to form target. You are given two strings s and t. Both of them are anagrams of each other and an integer k. Your task is to determine whether it's possible to split the string in s into k equal size substrings, rearrange the substrings and concatenate them in any order to create a new string that matches the given string t. So what happens is, let's say s is a, b, c, d. T is c, d, a, b. The first step is to split them into substrings. Split, substring, split, substring. So S become AB and CD. T is become CD and AB. And then what you want to do is you want to check whether you can rearrange these guys so that they're identical to each other. The simplest way to do this is S.sort, T.sort, and then compare. So when you sort A, B, C, D, you get A, B, C, D. You sort C, D, A, B, you get A, B, C, D. So you compare if the two of them are the same. If they are, you're done. So this is pretty straightforward again. So this is what I'm doing. S, I have an array of the substrings of S. I have arrays of substrings of T. I just break the substrings up. I don't believe you can do sorted. Yeah, you break the substrings up, and then I break up the substrings. You basically from I in range k, where k is n divided by k. The length is n divided by k. So if there are k substrings, the length of each substring is L. It's the length of S divided by k. And what I do here is I just break them up. Step 1, I break them into substrings, and then I combine them into T1 and S1, and then I sort T1 and S1, and I compare if they're identical. If they're identical, we're good. If they're not identical, we fail. Note that one thing, it says here, rearrange the substrings. So I thought that meant that you can, for instance, if your substring is VJDK and JVDK, you can rearrange JV to VJ. That's what I thought, but actually you can't. So that's why I had the sorted before. Yeah, this again is not too difficult. So let me see. We should do all operations into all index and recursion, find the best solution, optimize by using 3D DP. Oh, interesting. I'll take a look at it. I didn't do the DP. I'll talk about what I did. And then I'll talk a little bit about DP, see if I really understand. So basically, you're given an integer array nums, and 3 integers k, op1, and op2. You're supposed to perform the following operations. Operation 1, you can do it op1 times. You can choose an index and divide by 2, rounding up to a nearest whole number. And then operation 2, you can do it op2 times. Is choose an index. If it's larger or equals to k, then you can subtract k. So the way I did it initially is I just sort the array. This is the way I did it. And then I say if everybody who is larger than 2n, I will do operation 1 and operation 2 on you. So 19 is larger than 2n. I'm going to do operation 1 first, divide it by 2 to get 10, and then OP2. Yeah, so and then I do OP2, which is what you call it? Yeah, 10 minus 3 is 7. So 8, same thing, because 8 is larger than 2n. I can divide by 2, it gives me 4, and then I can minus 3, which gives me 1. Yeah, so that was my logic. I find all the people who are larger than 2n, and I apply both operations to them if I can, until I run out. If I run out, then too bad. Yeah. And then the next thing I do is, if you're not larger than 2n, then what I want to do is I will pick the smallest people that are able to reduce by k and reduce them. So let's say k is 3, right? I can take this, I can turn it 0. I can turn this into 0. So all the people that can do OP2 on, I just reduce them. So in this case, OP2 is 1, so I can only pick 1. I will pick the 3. So I get 7, 8, 0, 3, 2. And third step, I find the biggest one and divide by 2 if there are any remaining operations. In this case, there are no remaining operations, but life goes on. Yeah. So that was my basic strategy. I'm gonna basically do this greedily and say in the first phase, I find everybody is bigger than 2n. I'll apply both operations on them. If they're like between k and 2k, then I would basically still apply operations on them depending on what they are. And then finally, if they are less than k, then I can only do OP1 on them. Yeah, so that was my plan. But I think there's some off by 1 error. I ran into some off by 1 error when I had to deal with this, because when you divide by 2, you also round up. So the round up causes problems, depending on whether the number is even or odd, or whether k is even or odd. Actually, when k is odd, it causes problems. When k is not odd, there's no problem. So that's not great. I will try in the k equals to 3. So Sriram Raj Kumar, in this case, I will do OP1 first and then OP2. So OP1 will divide this by 2, will give me 5. And then OP2 will minus 3. 5 minus 3 is 2. So that will work. That one is not the problem. The problem is when there are like multiple numbers that are about the same. And then, when I divide an odd number, I round up. When I divide even number, I don't round up. So I get like off by 1 error. Yeah, so I should pick the odd numbers. Yeah, if I want to find out, if I want to pick the guy to divide to subtract k, I need to pick the odd numbers first. Is what I'm saying. Yeah. So Voxal, do you do the same thing? Yeah. Do you manage to do it? So Voxal, do you manage to do the same thing, right? Yeah, do all the index in recursion and find the best solution by optimizing 3D TP. Yeah, I'll think about DP one. I think the DP is probably the right way. The way I feel like this seems very attractive, but when you actually do it, there's all these weird off by 1 errors that I have no idea how to deal with. Okay, let's talk about question 4. So question 4 is maximize sum of weights after edge removal. There exists an undirected tree with n nodes numbered 0 to n minus 1. You are given a 2D integer array edges of length n minus 1 where edges I equals to blah blah blah. Yeah, so it's basically a weighted undirected graph. It's a tree, which means there are no cycles. Your task is to remove 0 or 1 edge such that each node has an edge with at most k other nodes where k is given. The sum of the weights of the remaining edges is maximized. Yeah, so the sum of the remaining edges is maximized. So I think, So I think this is basically a DP problem. I'm not sure. So the way I would approach it is I will find all the, okay, let me just go over one example first and explain why I think it's a DP problem. So for instance, in this example, this highlighted thing shows the graph here, and k equals 2. Because k equals 2, this guy is in violation. So he needs to delete 1 edge. So here he deletes the 2 edge, and then now he's good. So since he is only him, he's the only guy in violation, you delete the cheapest edge. And then this example, let me just draw it out. 0, 1, 5, 1, 2, 10, 0, 3, 15, 3, 4, 20, 3, 5, 5, 0, 6, 10. Okay, in this example, k equals to 3. 1, 2, 3, 1, 2, 3. Oh, wait. 0, 5, 15, 3, 4, 10, 3, 4, 20, 3, 5, 5, 0, 6, 10. Yeah, so in this case, you're all good. There's nobody's violation. However, if k equals to 2, then this guy with violation, this guy with violation, and the cheapest way is actually to delete this node. It's the cheapest way to delete this node, and then you solve all your problems. So I think this is a DP problem. Basically, what you need to do is you need to find first, just find all the nodes that are in violation. Find all the nodes in violation, and then you find all the edges that connects to at least one of these nodes in violation. So remove all the edges that don't connect to a node in violation. And then what you want to do is you want to say, okay, for each node in violation, this is how many edges I need to remove from it. And then you just test. It's a DP, it's basically a DP. And you just test with this edge, without this edge, with this edge, we remove this edge. I think that's the solution. I'm not sure though, because these numbers look extremely large. Oh, this is not a big deal. These numbers are pretty large. So I don't know if the DP, so if what I'm thinking will work. This is also a tree, so maybe a greedy algorithm will work. So a greedy algorithm is not that simple. So if this is a tree, and you say that k equals to 1, then these 3 nodes are in violation. And to fix this, you can either remove this and this, or you can remove this and this. Yeah, obviously removing this and this will be cheaper. Yeah. So I think it's a DP problem. I still think this is some kind of DP problem, because it's not very obvious which one do you want to remove. If you just look at this one, if you look at an edge in isolation, you look at its 2 neighbors, you can't tell whether it's better to remove this. Yeah, you look at the rest. For instance, if this is 100, then you should remove this and this. Yeah, so it's not so clear. Like when I look at this, yeah, look at just this guy, I can't tell whether I should remove him or not. Whether I should remove him or him. So I think this is some kind of DP problem. You cannot be greedy about it. I don't think you can look at it locally. Unfortunately, I didn't have time to complete this problem. For question 3, yeah, I guess you can. I think the DP is better. I think the DP is more for direct. I think greedy should still work, but it's not that simple. I'm probably gonna try and fix my greedy solution. You are streaming live? Yeah, but I don't give the answers, right? I only review the answers after the stream. That's not cheating. Yeah. So during the stream, you don't get any answers. You don't get to see me code. Yeah. No worries. But welcome. I don't think I recognized your name before, but welcome for joining. Welcome to the chat. Yeah, and also, if yeah, I'll be very frank. If you're trying to cheat, I'm not the person you want to cheat off of. Yeah. So Chirag, Aparat, the conclusion for third, I think you should try DP. I think that's probably the easier way. I'm gonna try the greedy solution again. I'm still convinced that it's gonna work, but yeah, we'll see. Yeah, cheating is bad because LeetCode is actually really good at detecting people who just copy paste. They are very good at it. If you change a little bit, then they will not be able to catch you so easily. But if you copy paste, yeah, or if you just change like variable names, it's very easy to detect. It's super easy. So yeah, copy pasting is not a good idea. Yeah, I used greedy in Q3 to get wrong answer. I also used greedy in Q3 and I also got wrong answer. So yeah, that's not fun. Yeah. I just explained Q3, so Suresh Chelani. I will release the VOD and then you can look at timestamp and then you can look at what the explanation was. Yeah, unfortunately I don't think I can explain it again because it is getting late, so I have to log off pretty soon. Yeah, let me see. If there's nothing else, yeah, sorry about that, Suresh Chelani. But thanks a lot. I'm seeing a lot of unfamiliar names on the stream. So thanks a lot for tuning in. I really appreciate all of you guys. Come back next week. I do this every week. Next week, I'll be streaming the weekly contest since there's no bi-weekly contest. So I hope to see you in about exactly 7 days. Meantime, keep on coding and I wish you all the best. Yeah, I'm signing out now. Thanks a lot and good night. Bye. Yes, I stream every week. I stream the bi-weekly contest if there's bi-weekly. If there's no bi-weekly, I'll stream the weekly contest. So pop by.